So, following in the footsteps of Humphrey Davy, we took electric power, ran it through water, and out comes oxygen and hydrogen. So, this was a chemical change. We caused a chemical reaction using the energy of electricity. And so now the challenge is, or the goal here is to see if we can write out a full balanced chemical equation of water, and thereby arrive at and discover, I know you might already know what the chemical formula of water is, but discover how it was discovered initially. How did we originally know, or initially know, that water was H2O, not HO or HO3 or H3O, something like that. So let's figure out, the goal here is to deduce from first principles the chemical formula of water. So the first step is to realize we are still obligated to follow the conservation of mass. So matter cannot be created or destroyed. So on the reactant side, the amount of atoms over here must equal in number the amount of atoms over here. We can't lose atoms or we can't gain atoms. And just to write down and recall what a balanced chemical equation is, we already did this for magnesium, and so you'll remember. So this is just an example that we've already done. Magnesium metal, when it reacts with hydrochloric acid, forms hydrogen gas and MgCl2. That's dissolved in water. And then to balance this, we saw that there's one Mg here, one Mg here, so that's okay. We saw one H here, two H's here, so we just put a 2 here, and that means that we have 2 molecules of hydrochloric acid. And now I have 2 Cl's here, but I have 2 Cl's here, so everything's balanced. So 1 magnesium plus 2 hydrochloric acids gives me 1 diatomic molecule of hydrogen and MgCl. So here's an example of a balanced chemical equation. So can we do this? The challenge is, can we do this for water? So Humphrey Davy was actually not able to do this. It would have to, the formula for water would have to wait a few decades, and there was 2 key pieces of information that had to be discovered before scientists could deduce the chemical equation that describes the reaction that we just caused. And so I'm going to give you these 2 pieces of information right now. And one is, we now know, and this was discovered in the mid-1800s, that the chemical formula of hydrogen is H2. So the chemical formula of hydrogen is H2, and we now know that the chemical formula of oxygen is O2. So basically, we know the form of the products in this chemical reaction. We don't know, let's not write down that this is H2O yet. So this is the first thing we know. The second thing that had to be, that was discovered several decades after Humphrey Davy did his work, was this idea that equal volumes of gases have equal molecules of gases. And it's just a very simple idea. Basically, if I have 2 balloons and one balloon is 3 times as big as another balloon, no matter what types of gases, chlorine gas, hydrogen gas, nitrogen gas, methane gas, is in this balloon, and what type of gas is in this balloon. They could be the same gas, different gas. No matter what, the volume is proportional to the number of molecules. So if I have a balloon over here that's 3 times the volume as the balloon over here, and this has methane and this has nitrogen, I know I have 3 times as many methane gas molecules as I do nitrogen gas molecules. And so that's another key piece of information to keep in mind when you try to deduce the balanced chemical formula of the formation of these two, of the breaking apart of water. And let me give you one final little clue to kind of focus your attention in the right direction. And that is using this second piece of knowledge that had to be acquired before the chemical formula of water could be deduced. This notion of equal volumes of gases have equal molecules of gases. We have information in our lab about this. So we have a volume of hydrogen that we produced, and we have a volume of oxygen that we produced. Now, what I got in my lab was something like 5 centimeters of hydrogen and 3 or 4 centimeters of oxygen. So it's a very finicky part of this experiment. So I'll just tell you what most scientists have obtained over the past couple centuries when they've run this experiment. And what most scientists have found is that there's usually twice as much hydrogen as there is oxygen. So the volume of hydrogen is 2 times the volume of oxygen. So I'll just leave you with that other piece of information that's been found and accepted over the past couple centuries. You may not have got that. I didn't get that. But for our purposes here, let's use this ratio of 2 to 1, hydrogen to oxygen. All right, I'll see you in the next video.